This is section 4.8, part B. We're now going to look at simplifying radicals using the quotient property. Remember that when we have a quotient, it is okay to separate the numerator and the denominator. There is one important thing that we maybe haven't talked much about yet. Didn't come up too often with the quadratics, but we do not want to end up with a radical in the denominator. So we're going to do everything we can to avoid that happening. In this first one, it's definitely okay to split up the numerator and the denominator. The square root of 3 on top, I really can't do anything about that. But the denominator comes out perfectly. The square root of 4 is 2, and the square root of x squared is just x. So I like that answer. No square roots in the denominator. Looks good. All right. Take a look at number 2. And let's sort of think ahead before we start separating. If I took the square root of 10a and put it over the square root of 18a to the 9th, does the square root at the bottom come out evenly? It doesn't, right? Square root of 18, not a perfect square. Square root of 8 to the 9th, I can't divide that 9 by 2. So what I'm going to do here instead is ask myself if I could maybe simplify this fraction a bit. And the answer is yes, I can. Let's simplify the fraction, reduce it to lowest terms before we separate the numerator and denominator into separate radicals. 10 over 18 can reduce to 5/9. And if I subtract the exponents, it's really an a to the first. So 9 minus 1 would be a to the 8th, but it's going to end up in the bottom where most of the a's were. Now how do you like the idea of taking the square root in the denominator? Now it looks a lot better, right? It is going to come out evenly. So we'll go ahead and separate. Once again, the square root of 5 on the top doesn't come out evenly, so I'm just going to have to leave that the way it is. But in the bottom, I have the square root of 9, which is 3. And dividing the exponent by 2 makes that a to the 4th. Once again, I do not have a square root or a radical of any kind in my denominator. I'm happy with that as a simplification. All right, in example 3, we need to remind ourselves that it's not always in our best interest to simplify or reduce a fraction. In fact, here you'll notice that if I were to reduce this, let's just look at it once. 10 over 16 would be 5 over 8, and subtracting the exponents would put an a to the 5th in the bottom. But did I really do myself any favors? I could have taken the square root of the denominator originally. It would have come out perfectly. And in the reduced form, it doesn't. So we're going to say only reduce if it's helpful. In this case, it's not. So I'm just going to separate the numerator and the denominator. On the top, the square root of 10a is just going to have to stay the way it is. I can't do that. But I can do the square root on the bottom for a cubed. And once again, we consider this simplified because there's no square root left in the denominator. All right. For our last example here, we're going to look at a cubed root of a quotient. And I certainly could break this up, but I'm also going to notice there's some things that I could reduce. Let's think about whether we do or don't want to reduce. I'm going to start by saying right now that 24 in the denominator does not have a perfect cube root. So I might as well try reducing. Maybe it'll get better. 15 over 24 can divide by 3 top and bottom. 5 over 8. Okay. I like that 8 a whole lot better in the denominator, since the cube root of 8 comes out evenly. All right, what about the ends? Well, right now in the denominator, I've got that 10th power. 10's not divisible by 3, so it's not great yet. If I subtracted my exponents, I would end up with an n to the 8th, and 8 is also not divisible by 3. What I'm going to do is just partially reduce the n's. I'm going to divide each one of them by 1 n, or n to the first. So I still have n to the first up here, but I have n to the 9th on the bottom. And again, what I really did was under that radical, I divided by n, and I did the same thing top and bottom. So I'm really dividing by a form of 1. It's okay. All right, this looks a lot better. Top is the cube root of 5n, which doesn't come out evenly, but that's okay. Bottom is the cube root of 8n to the 9th, which does come out evenly, which is great because it's the down denominator that I need to come out evenly. Cube root of 8 is 2, and dividing that gives me n to the 3rd. So rule of thumb on fractions under a radical, don't necessarily reduce just because you can. Always think about that denominator. You want the denominator to come out evenly when you take the square root or cube root or whatever it is you're working with. All right, that's the end of part B.